The intersection from n equals 1 to infinity of the open intervals from 0 to 1 over n. What is that? Well, we're first going to take the open interval from 0 to 1 and intersect it with 0 to 1/2. This is going to be 0 to 1/2, right? Then we intersect that with 0 to 1/3. This is going to be 0 to 1/3. And we keep intersecting these open intervals to get what? The empty set. Don't believe me? Let's prove it. You don't believe me? Let's do this by the sake of contradiction then. So let's say that you are right and there is an element that does exist in this intersection. It is not empty. Let's call that element x. The trick here, though, is that you saw those intervals get smaller and smaller and smaller. So for any x, I can find an interval that x is not included in. And if x is not included in that interval, then clearly it's not included in the entire intersection, because the intersection is what is in every single interval. And this is the basic idea. So for our proof, suppose for the sake of contradiction that there does exist some x greater than 0 such that x is in our intersection. And then we find our contradiction. To prove this idea rigorously, this idea that if there's any x, there's a 1 over n smaller than x, we're going to use the Archimedean principle, which just says if you have any real number, there exists a natural number bigger than that. But we want this in the opposite direction, right? With our x and r, what'll end up being 1 over n. So we just manipulate this principle a little bit. So for r x greater than 0, surely if x is greater than 0, then 1 over x is a real number, and then we can just apply the rest of the Archimedean principle. And if n is greater than 1 over x, clearly x is greater than 1 over n. And we use this. So there exists some n within the natural numbers such that x is greater than 1 over n, so x is not in the interval from 0 to 1 over n, and furthermore, the intersection. And there's our contradiction. We said that x is in the intersection, but it's actually not. And because there's no x in the intersection, it's got to be empty. And we finish with a QED. Or we could even use the contradiction symbol, right? Two arrows together, contradiction.